Attractions and bonds. Basic building blocks of matter, atoms can't stand being alone. They like to interact with each other. Why? It's simple. They attempt to become stable by having a complete valence shell, which contains as many electrons as possible so that they achieve noble gas configuration. As noble gases are already stable, they don't need to react. Okay, but what about unstable atoms? Elements from the first, second, and third group of the periodic table have few electrons in their outermost orbitals. By losing those electrons, they can achieve noble gas configuration. Similarly, nonmetals that have close to 8 electrons in their valence shells tend to accept electrons. Electronegativity is a measure of how strongly atoms attract bonding electrons to themselves. The higher the electronegativity, the greater an atom's attraction for electrons. The difference in electronegativity between atoms determines the type of chemical bonds between them. When two atoms attract electrons equally, like in a hydrogen molecule, you will get a symmetrical nonpolar covalent bond. Polar covalent bond occurs when the electrons are shared between two atoms, but one atom attracts them more than the other, like in the water molecule. In ionic bonding, there is a high electronegativity difference between the atoms. Ionic bonds require an electron donor, often a metal, and an electron acceptor, a nonmetal. In sodium chloride, commonly known as salt, sodium metal loses its electron to become a positively charged cation, whereas the nonmetal chlorine accepts this electron to become a negatively charged anion. By this ionic bond, both elements can achieve noble gas configuration.